In the fast-evolving world of machine learning, the rise in energy demands presents major environmental issues. ICT's electricity use is on track to exceed 14% of global greenhouse gas emissions by 2040, highlighting a critical need for sustainable IT approaches. Enter GAISSALabel, a groundbreaking tool evaluating ML systems' energy efficiency. Covering evaluation for both training and inference stages, offers easy-to-understand energy efficiency labels for energy evaluation. It represents a crucial step in balancing high-performance AI systems with their environmental impact. So this is the GAISSALabel homepage. From here, we can access tools for evaluating the energy efficiency of both training and inference phases. Currently, we have nearly 2,000 models registered, predominantly from Hugging Face repositories, and we continuously expand our energy database with user inputs and new repositories. Let's explore the training evaluation. There are two primary methods to introduce and evaluate the training of our machine learning model. The first option is through a form-filling page. Here, we can either select an existing model from the database to modify it or add a new model's training. For example, let's retrain the well-known Hugging Face model, DistillGPT-2. We input relevant metrics for evaluating its energy efficiency, such as carbon emissions, model file size, performance, like perplexity for DistillGPT-2, and others. These preliminary metrics can be flexibly altered later. After filling in the details, we can add more specific information about the training process. Finally, we're ready to generate the energy label. Voila! We have an energy label that grades the model's training energy efficiency from A to E. This label includes individual ratings for each attribute we introduced. Additionally, below the energy label, there are several recommendations for improving the metrics. Another way to generate the energy label is through a file. This file is created using a plugin in our Python training module, which automatically generates the necessary metrics for our energy efficiency classification. Of course, we can also review previous trainings done with the tool. Its energy label shows that if certain metrics, like performance metrics, were unavailable during energy efficiency calculation, the system is flexible enough to compute the label without them. Now let's move on to the inference phase. To evaluate the inference energy consumption of DistillGPT-2, we could manually enter data through the form as the training phase. But let's explore using the file input option. Suppose we have the model's performance data and its definition file. By following GAISSALabel guidelines, we incorporate its plugin and execute it. We specify the model file location, output directory, and file name. The plugin then computes critical metrics, including model size, file size, and flops. Additionally, as per GAISSALabel's instructions, we integrate CodeCarbon into our application to track runtime, CO2 emissions, and power consumption during model inferences. Next, we upload the files generated by both the GAISSALabel plugin and CodeCarbon to GAISSALabel and click on Generate Label. The metrics are automatically filled in. We input the known performance score and, if desired, additional information before generating the energy label. We now have the label for the inference phase. Finally, consider the scenario where we need to modify the metrics used or adjust the boundaries for each classification. In the near future, local or international directives, or even standards, may emerge to calculate the energy efficiency of ML models. GAISSALabel, through its quality assurance role, allows for the customization of energy efficiency label definitions. Once logged in this role, we can add new metrics, alter the computation methods, or modify the range scales. Let's introduce a new metric for CPU count, while readjusting the weights accordingly. After adding it, we return to our previous training example in the form, input the new metric, and generate an updated energy label that now takes this new metric into account. In conclusion, GAISSALabel allows us to evaluate the energy efficiency of the training and inference phases of our ML model. Through multiple functionalities, our tool represents a significant advancement in integrating environmental sustainability into ML practices.